Hi. Well, first I want to thank the organizers for the invitation. I'm very happy to be here. The topics in which I work is the collection of mobility data that can apply to humans, can apply to other systems. And specifically, there's two applications. One is on transport and one is on water. And I think the link with the themes that we've heard about today is the unprecedented amount of data that's been collected in the past years through various technologies which have emerged. And so I'd like to give a form of an instantiation of that story in the context of traffic to link it to all the other talks we'll hear about, Roger with water and Ron with atmospheric chemistry and the environment. In the context of traffic, it's interesting because we've really witnessed a revolution in traffic information technology in the last 5+ years, mostly due to the explosion of the smartphone. And if you remember, it was not so long ago that if you wanted to go to a website and figure out traffic information, it would look like something you see on the bottom right here. And practically the only way for people to get around and get a sense of how long it's going to take them to the destination would have been to look at one of these signs on the freeway. You probably have seen them if you've driven around. They're actually operated by UC Berkeley, by algorithms run by our students. And that was pretty much it. And I think that's mostly due to the fact that if you think about data today and the way data populates these systems, data is collected by means which so far have been very traditional, hardwired infrastructure in the ground, maybe video cameras, sometimes some traveling RFIDs, but overall very traditional and very partial infrastructure, especially in a state like California, which has had its financial challenges. It's been hard to deploy these at a global scale. So I think one of the revolutions which have really made life different is the amount of cellular and mobile devices that have populated our existence in the past couple of years. So it's pretty hard to read these small numbers on the graph, but I think what's amazing is that if you look at this upper curve, and it's really from almost a year and a half ago now, the Android was about to supersede the number of PCs. And I mean, today, the number of Androids produced every day or activated every day is on the order of 1.3 million every day. So this is just for one specific brand of phone, which is the dominating phone. But overall, it's clear that with operating systems like the Android, in which it's hardwired that now data is going to be collected, whether you know it or not, whether you want it or not, and it's going to be transmitted to whoever is in charge of that operating system, whether it's a Google phone, whether it's a Samsung phone or whatnot, then it completely changes the way mobility can be measured and the way mobility can be managed. So a good graphical way to illustrate this is if you look again at what a speed map would have been 5 years ago, if you wanted to just look at it on a public government website. That's the left picture. And the right picture is something that all of you have probably seen on your smartphone. Google has it, Bing Traffic has it, Inrix Traffic has it, and there's another 5 companies who produce such traffic estimates. And so in the present case, this is something we produced in 2009 after launching what was the first traffic app ever launched in North America on Raymond Symbian phones. And the difference in information content is specifically due to mobile phones. So the mobile millennium was one of the early instantiation of that philosophy, and with, I think, now has taken off at global scale. At the time, we had 5,000 downloads, which was astronomical. Today, with Google Play and the iStore, I mean, the scales are different, obviously. But the bottom line is that enabled us to construct a platform which gathers 60 million GPS points just for California every day from brokering agreements we have with various companies that are in this business to produce this type of data. There's something which is quite interesting is if you think about data visualization for traffic, it's not changed much, and there's still a revolution to come because whatever data provider you're using, the displays of basically generic color map is pretty standard. Just to give you a flavor of what that data looks like, if you were going to collect one GPS data point every minute on every taxi in San Francisco, well, that's what it looks like. Obviously, time is accelerated on this plot. One frame is every 30 seconds. And basically, the red dot is a taxi, and the black dot is a GPS point the taxi leaves behind every minute. What's amazing about this data is that, by the way, this represents about 0.5% of the data we have for California. So you can see this looks big, but this is not that much. And what the data we have is probably ridiculous compared to the data that Google and other companies have. But I think what's striking here is that not only in terms of live information, which you can provide to the public, also in terms of understanding and constructing maps and representation of the environment, just after 1 day of data, you can already reconstruct a full map which includes very precise locations for the arterials. You can even infer buildings. If you've been to the international terminal at the San Francisco airport, that's where it is. And you can see it because of the GPS occlusion. You can even see the exchanger of the international terminal versus the domestic terminal. So the point is, if you think about companies like Google who have expanded to places where there is just no maps, just crowdsourcing information like this has enormous values, and one of which, or I would say the first of which, in terms of beneficiaries, was traffic. So what does that data look like if you zoom on it? This is an example of a couple miles of freeways. This is time. This is post-mile. This is on I-80 in the East Bay here. And each dot is basically what your phone tracks every 3 seconds. If you have an Android, most likely someone, so either the manufacturer or Google, is capturing that data. That doesn't mean they transmit it. That doesn't mean they store it. I mean, there's a lot of different issues of how they deal with it, but has the ability to capture that data, which shows exactly how fast you're going. If you're in an accident, like here, you're going slower. That's why it's red, and so on. That's 3% of traffic. So with 3% of traffic, with 3% of us carrying a phone that transmits a point every 3 seconds, you need very few algorithms. You can practically read and show traffic. And it's fairly accurate. I mean, you can really read the speed. It's like 10 miles an hour, 20 miles an hour, and so on. That's something that was unthinkable even 5 years ago. Now, I think where we come in is like trying to make sense of information. In practice, you don't get all that information for various reasons, and privacy is one of them. So if instead you just got this type of information, which is a subset of the previous plot, but say you do occlusion here, so you don't want to collect data here because otherwise you could track people, then where the math becomes interesting is how to reconstruct the information where you don't have. So this is the full set of data. This is what's maybe more realistic to gather, and that's what a good algorithm should produce, which should be fairly similar to what you're collecting if you were collecting things everywhere. And so these are the types of problems that are currently being worked on. I mean, this is a very fragmented market. There's a lot of different entities which have the data. Nobody has all the data. So the game here is, with very fragmented subset of the data, can reconstruct the whole set of information. So I'm going to skip this because I don't want to derail the whole panel. But I think what's interesting about data in mobility in the urban environment is that the sky is truthfully the limit. I mean, today, there's lots of groups, including ours, who do research on data which is collected from planes, who just gather traffic information. That's very helpful in conflict zones to follow POI, people of interest. And typically what's done there is try to reconstruct traffic so you can kind of re-identify where a vehicle reappears after occlusion. We even have reprogrammed a satellite with a DWR that now orbits around California to gather traffic information. So literally, the sky is the limit. But all these pictures give you a sense of, if you want a full picture of mobility in an urban environment, some things have provided breakthroughs. And that would be GPS on board vehicles, that would be smartphones, and that would be aftermarket devices. But the truth is the complete picture really comes from fusion of all these sources. And these are things that we're interested in doing. And so that creates a lot of interesting questions for public agencies. If you're the state of California and you want to buy data, today there is no procedure because you don't know what does it mean to have a good GPS point? What does it mean to have a high quality feed? What does it mean? Should you pay by the kilo? Should you pay by the pound? Do you pay by the megabyte? Do you pay, I mean, like, how do you quantify the value of a GPS point? And so the type of problems that we're working on is specifically working on procurement procedures with states to help them procure this data. They're used to the old model where you take your infrastructure, you put it on the ground, you start collecting data, and that's it, you're done. Today, you have to talk to 10 companies and get that data, and there's no procedures for it. So one of the first procurements we did was last year, and this was the first time that that data was officially bought on behalf of the state. It was bought by Berkeley to test and define the procedures for it. And it's going to be the same situation in many different fields because I think the main difference with the previous era is that next generation data, whether it's traffic data, whether it's environmental engineering data, whether it's social data, whether it's mobility data, health data, is going to be vastly, predominantly collected by the private sector, which means public agencies will have to define themselves new ways to acquire this data. So maybe one thing I want to show, I mean, so some of you have probably seen this movie, The Italian Job. So at some point, the alleged creator of Napster hacks the District 7 traffic command center in LA, and they shut them down and then starts to create accidents to allow some villain to be caught by his friends. OK, so this is a good motivation slide for what we're doing now. not so much to hack into that system. Actually, we are working with that district. But I think that what we're interested to do now that all this data is available is to use it in a way to generate a different way to manage traffic. Traffic, especially in California, but in other places of the world too, has been managed in a very traditional manner. Most of the time, if you're lucky, you have metering lights. These are the lights that prevent you from entering the freeway at a too high rate, which would clog the freeway. And that's pretty much all there is. And what we're going to do in Los Angeles is we're going to take over an entire freeway, most likely 710, but we don't have a confirmation yet. And we're going to start ourselves operating the traffic lights leading to the freeway of the neighboring arterials. This one is taken in Oakland, but imagine this was in LA. And then also taking control of the changeable message signs, for example, to tell them accidents, exit the freeway, so you have response models. If you put zombie running on the runway, how many people will actually exit because they're afraid of zombies? Well, it's a non-zero number. So if you put like a major ballpark event, a certain percentage will exit the freeway as well. So understanding how you use that information to manage traffic is something we're going to work on as well. And then a smartphone app specific to the corridor, also that in a way that you can reach out to people. Again, if you're a commuter in LA today, you have really no way other than listening to the radio and looking at a traffic app to know what to do. And we believe that local really is the solution here. If you take a company like Google, they provide global products, but Google is not necessarily interested in having a specific customization of its app that is just for LA commuters. For that, you need community, you need a social network, you need people who are commuters there, and so on. And so this is part of the approach that we're interested to do, is to focus these tools on local communities to provide them information which they cannot get from global providers. And so for this, we're working with companies like Waze, for example, to use their social network data to understand how people post and what they do on the freeway. So I think the question of mobility management, now that all these data sources are becoming available, really becomes a systems integration problem. It's not just some public agencies going to the field, deploying their infrastructure, and trying to assess one part of the problem. Is that you have to tackle it all at once. You have to be able to reroute people in the secondary network. You have to be able to people to give them incentives to take public transport. And these are things which are not easy to do, and these are things where social has a lot of role to play. And that's mostly because it's a multi-jurisdictional problem. I mean, if you're dealing with this, then you're dealing with public agencies, with metropolitan planning organizations, you're dealing with transit agencies, you're dealing with sensing infrastructure, which is mostly owned by the public sector, but you're also dealing with public partners that are providing data. And so in a sense, it is a technology problem, it is a scientific problem, but it is also an institutional nightmare that needs to be solved, and that's part of the research. So in a very same way that helping agencies to do procurement was a challenge, and I think has been overcome in many ways, interjurisdictional collaborations for these problems is something which is far from being solved and has a lot of promising avenues. So I'm going to stop here because I think we have a panel, and we don't want to derail this, but I'll be happy to answer questions probably during the panel if that's easier. Thank you.
Thank you.